Perfect. Well, I'm Ann Carmichael, and I looked at one way to make the production process of superconducting coils easier, as well as quantitatively confirmed that their performance is not degraded during this process. Superconductors are material that can conduct electricity without resistance at extremely cold temperatures, and they're often used in large magnet applications such as MRI machines. One superconductor, Bi2212, is especially well suited for these applications because its superconducting properties are uniform in all directions, and its unique round wire geometry means that it's mechanically flexible. However, before it becomes fully superconducting, Bi2212 must undergo a heat treatment process. How this is done is Bi2212 wire is wrapped around a base, which then forms the superconducting coil. This coil is heat treated in the vertical position. However, these coils can be extremely large, so it can be very difficult to support the mass of the coil as it's loaded in the furnace for heat treatment. Because of this, it would be much easier to do this process in the horizontal position. The only downside is, like silly putty, these wires are extremely soft, so gravity causes them to sag downwards, which significantly decreases the performance of these coils. To compensate for this, a ceramic braid was added around the wires to help support it during heat treatment. This appeared to be successful when done in the vertical position. However, it was never quantitatively confirmed, nor was it tested in the horizontal position. To determine just how effective these braids are, two coils were analyzed. One was heat treated vertically, and one was heat treated horizontally. These coils were then cut open, polished, imaged, and analyzed to determine if the braid successfully kept these wires from sagging during the heat treatment process. How this was done was the distance between the rows of wires was analyzed to determine if the distance was uniform throughout the entire length of the coil. If the distance between rows was uniform throughout the length of the coil, it was determined that the wires did not sag during this process. However, if the distance between the rows of wires was significantly less towards the bottom of the coil, it was determined that sagging did occur during heat treatment. When both of these coils was analyzed, it was found that the distance between the rows of wires was uniform for both the horizontally and the vertically heat-treated coil, indicating that the braid was able to successfully keep this sagging from occurring. Since this sagging did not occur, the homogeneity of the magnetic field was significantly improved, and it also reduced the risk of the coil overheating. Since the horizontally heat-treated coil also did not have any sagging, this implies that horizontal heat treatment is a viable option going forward, which would make the production process of these coils much easier. In the future, this study should be replicated with a variety of coils to determine if sagging occurs when the coil is larger, as well with different braid materials to determine if other types of braids are able to support the coil as well during heat treatment. Thank you.